This video presents a set of desktop interaction techniques for performing operations in 3D environments. In each technique, the user controls one pointer with their right hand and another pointer with their left. Interactions shown later in the video were implemented with the Inventor toolkit and used two mice for interaction. However, the first set of interactions were implemented in the Sketch system. In Sketch, the user controls a one-button puck with their non-dominant hand and a three-button stylus with their dominant hand. We use a 12-inch square Wacom tablet that is capable of reporting the positions of both devices simultaneously. In the next segment, we will demonstrate two interaction methods for specifying the parameters of an orthographic camera. In the first technique, the user simultaneously controls the camera's translation, yaw, and film plane size. The camera rotates by moving one pointer in an arc around the other. By moving the pointers away from each other, the user scales the film plane. The user pans the camera by moving both pointers in unison. Pick correlation between the cursors and 2 points in the scene is maintained throughout. By pressing a button, the user switches to a second camera technique. In this technique, moving either pointer up and down changes the pitch of the camera. Moving one pointer in an arc around the other changes the camera's yaw. Once again, pick correlation is maintained. In either of these techniques, the user can view the world from the other side by first crossing their hands, clicking a button, and then uncrossing their hands. Drawing axis-aligned lines is an important operation in the Sketch system. While dragging out a line with their dominant hand, the user can concurrently make fine adjustments to the position of the entire line segment with their non-dominant hand. The user can also rubber band an axis-aligned line by starting the line operation when the 2 pointers are touching. Using a tearing gesture, the user can also rubber band lines that are not aligned to any axis. As the user lays out points for a polyline, they can also go back and edit previous points with one or both pointers. In this case, the user selects 2 points to modify. Borrowing ideas from tool glasses and magic lenses, the user can define a set of objects to duplicate by drawing a lasso. The encircled objects can be duplicated and dragged whenever the non-dominant hand cursor is within the lasso. Objects in Sketch are by default constrained to translate along a planar surface. So with one hand, the user can translate the car. Notice that the car wheels are grouped to the body of the car. To temporarily ungroup a specific wheel from the car, the user can simply select the wheel with one pointer and drag the car with the other. When the manipulation ends, the group constraint is restored. We now show how an object can be rotated and translated, either independently or concurrently. The user rotates the car by picking a point with one pointer and then dragging it in an arc around the other pointer. If both cursors move, then the user translates and rotates the car simultaneously. The axis of rotation is determined by the features that are selected with the 2 pointers. The user adjusts the pitch of the carport roof by selecting points on its side. We have added some features to the scene, including a windshield for the car and cutouts for the car wheels. We have also added a tailpipe and 2 puffs of exhaust. Each puff is associated with an interactive shadow. Shadows are drawn as though there were a directional light source aimed directly at the ground plane. When an object's shadow is translated or rotated, the shadowed object moves in the same way. 2 pointers are especially useful for many alignment operations in which one hand establishes a context for the other hand. In this next example, we want the small puff of exhaust to lie directly behind the tailpipe, but also be elevated high above the ground. To do this, we use one hand to pin the puff of exhaust in place, and then translate the shadow until it aligns with the tailpipe. Alternatively, the user may want to just elevate or lower the exhaust puff vertically. To do this, the user first pins the shadow with one pointer, while translating the puff up and down with the other. Lastly, we demonstrate how one hand can manipulate the camera, while the other hand manipulates an object. We grab the car with one hand in order to translate it. At the same time, we pan the camera with the other hand like a sheet of paper. This allows the car to translate all the way off the edge of the ground plane.